All right, so the first types of rational expressions that we're going to look how to simplify are going to be monomials. Monomial just means one term. It's going to be one term over one term. These are pretty easy. So the instructions would just say simplify, or they might say simplify the rational expression, something like that. And these are going to be pretty simple for you guys to do using your calculators. So, for example, it might say 12x to the third over 54x. So we can't do the x part in our calculator, but we can do the number part. So what you're going to do first is you're going to start with your calculator screen like this, and we're going to type in the fraction. We're going to type in the numbers because our calculator will simplify the fractions for us. So I'm going to type in the fraction by doing alpha y equals, so alpha y equals, and pressing enter. Alpha y equals and pressing enter. And the fraction is 12 over 54, so I'm going to type 12 over 54. And when I press enter, the calculator is going to reduce that fraction for me. So 12 over 54 is 2 over 9. So I'm going to write 2 over 9. Okay? And then I have to reduce the x's myself. So what I'm going to write is I'm going to show that there are 3 x's on the top, there are 1 x's on the bottom. So what I'm doing is I'm just expanding this form. 3 on the top, 1 on the bottom. And the way that it works is that 1 cancels out with 1. So these two cancel out. And what you want to do is you want to cancel until either all of them are gone on the bottom or all of them are gone on the top. So here we have all of them are gone on the bottom, and then we count up how many are left over on the opposite side. So the bottom is gone. The top has 2 left over, which is x squared. So I'm going to write x squared on the top, and that is my final simplified answer. 2x squared over 9. And that's it. All right, let's try another one. We're going to do negative 18k over 48k to the 5th. Actually, we'll do k squared. K squared over k to the 5th. So first, I'm going to take my calculator. I'm going to hit alpha y equals. Press enter, and I'll type negative 18 over 48 just to see what that fraction is. And what are you guys getting for your fraction? Negative 3/8, okay, perfect. Negative 3/8, okay. And then we're going to do 2k's over 5k's, okay. And then what do we do next? We cancel. I'm gone. The k's on the top are gone. And how many k's are left on the bottom? 3. So we're going to put 3 on the bottom. K to the 3rd on the bottom. Does that make sense?
Yeah.
Okay. Let's try another one. We're going to do 80 r to the 4th over 32 r to the 2nd. All right, what should we do?
Alpha y equals enter 80 over 32.
Okay, so our new fraction is 5 over 2. Okay. And can anyone tell without writing the r's down how many should be left over? Okay, so there's going to be 2 r's left over. I can tell because there's 2 on the bottom and 4 on the top. So if we look at this, 2 of the r's on the bottom are going to cancel with 2 of the r's on the top, and it's going to leave 2 r's behind. So if I write this out, 1, 2, 3, 4, 1, 2, 2 of the r's on the bottom cancel with 2 of the r's on the top, and it leaves 2 left over. So you can always do it without drawing it out, but if you need to draw it out, you can draw it out. It's up to you. All right, so I'm going to hand out the worksheet so you guys can practice these. We're going to be doing 1 through 6. 1 through 6 is what we're going to start with. So we're going to look at binomials and trinomials. So instead of just having one term over one term, they're going to have multiple terms. So binomials have 2 terms on the top or bottom. Trinomials have 3 terms on the top or bottom. If you look at your worksheet, if you flip it over to the back, number 17, this is a binomial over a binomial. It's 2 terms over 2 terms. Caitlin, if you grab the assignment in the back. And then if you look at number 18, you can see what a trinomial looks like, trinomial over a trinomial. So this is what we're doing next, but we're going to look at the ones where they are already in the factored form, because the factored form are the ones that are a little bit easier to deal with. So we're going to write down some examples of ones that have already been factored for us before we do some where we have to factor them ourselves. So first we're going to look at 6x times 3x plus 4 divided by 6x times 5x plus 6. So what happened in this problem is there was a binomial, there was 2 terms, and they factored out a GCF of 6x. And there was a binomial on the bottom, and they factored out a GCF of 6x. Okay? So if this is the case, then what we're going to do is we're going to look at the GCFs on their own, and we're going to see, basically we're going to look at them as though they were the previous problem, and we're going to see if anything could reduce or kind of cancel out. So if you look at the x's, what do you guys see about the x's? They're exactly the same, right? So if we look at the x's here and we compare them to the problems that we did to start with, we'd be like, oh, here an x on the top and the bottom, we cancel out, then we had 2 x's left on the top, and we wrote x squared was left on the top. Well, we didn't have any problems where they just completely canceled out, but that's what's happening here, is those 2 x's are actually going to completely cancel out and go away. And anytime you have something that completely cancels out, it doesn't give you 0, it gives you 1. Something divided by itself is actually 1. So x over x is 1. Same thing over here. If you were to take your calculator and say, okay, this is like a monomial problem. We've got 6 over 6. If you grab your calculator and have your calculator help you simplify that fraction, 6 over 6, it's going to give you 1 because you have the same number divided by itself. So 6 over 6 is 1. So the 2 GCFs in the front that they pulled out when they factored, both of those equal 1. And then over here, when we look at the parentheses, we see a factor on the top, a factor on the bottom. We can't reduce those because they're not identical. This is considered to be one whole group on its own. This is considered to be another whole group on its own. And so the final answer here is going to be 3x plus 4 over 5x plus 6. And this is the final answer.
So none are like the same number.
They're not like terms, basically.
Yeah, like
Yep. So the only way to cancel parentheses, we'll see in the next example, is if the parentheses are identical. So if the parentheses are not the same, you can't cancel them. So we're going to look at another problem here. We're going to do 8n times n plus 1 over 10n times n plus 1. And in this problem, again, we have a binomial over a binomial. In this binomial, they were able to take out a GCF on the top of 8n, and on the bottom, in the binomial, they took out a GCF of 10n. Now, this one's more interesting because the parentheses are identical. So this time, you're going to be able to say, oh, these parentheses, since they're identical, they cancel each other out. You say the top and the bottom are exactly the same. It's just like over here when we said, oh, this x on the top and the bottom, they cancel each other out. Or when we said, oh, the k on the top and the bottom, they cancel each other out. It's exactly the same. Except here we have parentheses. So whenever you have parentheses, it has to be the whole parenthesis that is the same as another whole parenthesis. And then that's how you get them to cancel. And then right next to it, we have an n and an n, and those completely cancel out. So whenever we deal with this, we can look at the GCFs, and we can cancel within the GCFs, and then we can look at the parentheses, and we can cancel parentheses as long as they're the same. Those are kind of like the rules. Over here, we have a GCF of 8 and a GCF of 10, and they're not going to cancel because 8 and 10 are not the same number, but they can reduce. So I'm going to take my calculator, and if I didn't recognize that, maybe if I'm not feeling very confident with my division, I'm going to go ahead and just type this in, 8 over 10, and let the calculator reduce it for me, and I get 4 over 5. And if you feel comfortable doing that in your head, that's fine, but you can also let the calculator do it. Now, sometimes you have problems where there wasn't a GCF at all. So here's one where we have the trinomials, which are the x problems, where you look for something that multiplies to a certain number on the top and then adds to a certain number on the bottom. So for this problem, they had a trinomial on the top and a trinomial on the bottom, and so they ended up with 2 sets of parentheses on the top and 2 sets of parentheses on the bottom, and we just want to see how we could cancel stuff out. So what do you guys notice? Do we have any identical parentheses? Yeah, we can cancel out the x plus 5 on the top, x plus 5 on the bottom, and then we have some parentheses that are left over, and those cannot be canceled. Those have to stay behind. So x minus 3 and x minus 7 cannot be canceled, so those are in the final answer. Okay, so what you guys are going to work on next is, if you look on the worksheet, we have 7 through 14 is what we can work on next. So are there any problems from 7 through 14 that if you just look at them now, they might feel intimidating or you're not really sure how you might do them? 7 through 14, you're going to finish the front side of the worksheet. 13? Okay, so let's look at 13. Do we see anything on the top and the bottom that are identical? Parentheses, part of the GCF, the b squared. Yeah, b squared and b squared, those are identical, so we can cancel out b squared and b squared. Okay? Anything else? B plus 3, those parentheses are identical, those can cancel out. Okay? 8 over 7, is that going to reduce? Probably not. If you want to double check it and see if it reduces, you can. Or if you're confident that you know it's not going to, then you can just write it down. So 8 over 7 does not reduce. And so 8 over 7 is our final answer. Is there another one that feels intimidating? No? Okay. All right, so go ahead and work on those ones. We're finishing the front side of the worksheet. So for this last bit, we're still going to deal with binomials and trinomials, but this time we have to factor them ourselves. All right, so go ahead and put your cell phones and your earbuds away. So binomials and trinomials. And here we need to factor. Binomials and trinomials, but here we need to factor them ourselves. All right, so if we have p squared minus p minus 20 divided by p squared plus 8p plus 16, how would I factor each of these? What type of problem is this? It's the x thing, right? Both of them are the x thing because they're both trinomials. So for the top one, I'm going to look for two numbers that multiply to negative 20 that add to negative 1. And for the bottom one, I'm going to look for two numbers that multiply to 16 and add to 8. So what multiplies to negative 20 and adds to negative 1? 4 and 5. Positive 4, negative 5. Okay. So p plus 4, p minus 5. With the other one, we have to multiply to 16, but add to 8. What numbers do that? Multiply to 16, but add to 8. 4 and 4 would do that. 4 and 4. So p plus 4, p plus 4. Okay, so now it looks like the previous problems, and now we can see what cancels. So we can't cancel 3. We can't. So if we look, let's look at our previous notes. So over here, when we were looking at our monomials, we weren't able to say like, oh, look at all these x's. We have all these x's on here, let's cancel all the x's. We weren't able to do that, right? Whenever we had these x's, we saw one x on the bottom, one x on the top, and that's all we could cancel. Does that make sense? And so here, same thing with the parentheses. We can only cancel one set of parentheses with one set of parentheses. So we're going to cancel 1 with 1, and that's all we can cancel. And then the extra set of parentheses we've got, that's what's left over. That's our final answer. So we end up with p minus 5 on the top, p plus 4 on the bottom. That is our final answer. Okay, we're going to try a binomial problem, and this is going to be good for if we forgot how to use our calculator to find the GCF. So 27m to the second minus 72m over 63m to the second minus 36m. Anyone remember how the calculator can help you find a GCF between two numbers? Yeah. Math button to get to this screen. go over to number, and which number do we click? 9. Click number 9, okay? And we're going to find the GCF between 27, comma 72. And remember, the comma is right above the 7 button. Okay, so what's the GCF between 27 and 72? 9. Okay, so I'm going to take out a 9. And then what about the m squared and the m? What can I take out between the m squared and the m? Just one m. Whatever's smaller, that's what I can take out. Okay, so 27 divided by 9 is 3. 3m minus 72 divided by 9 is 8. And we already took out the m, so that's gone. Okay? On the bottom, we're going to look at the GCF. So we're going to hit Math, go over 1, click 9, 63, comma 36, and the GCF is 9 again. Okay, 9. What about between m squared and m? We're going to take out an m. Okay. 63 divided by 9, 7. Okay, 7m minus 36 divided by 9, 4. Okay, and we took out the m already. All right, so the parentheses are different, so the parentheses can't cancel. Nothing in the parentheses can cancel. But what's the same? Yeah, the 9s, the m's. We can get rid of those. Okay, so we are left with our parentheses. 3m minus 8 over 7m minus 4. There's our final answer. Okay. All right, let's try some that are on your sheet, because there's quite a few on there. All right, which one would you guys like to do? 18? Okay. So for 18, it's got a trinomial over a trinomial. So we're looking for two numbers that multiply to 64 and add to negative 16. And then two numbers that multiply to negative 56 and add to negative 1. Multiply to 64, add to negative 16. So I'm going to do 64 divided by x. We're adding to a negative, so I'm going to go over to the negative side. Adding to negative 16. Anyone see it? What numbers multiply to 64 but add to negative 16? 8? Negative 8, negative 8. Okay. And then we got to look at what multiplies to negative 56 and adds to negative 1. Okay, so we're going to have a minus 8, a minus 8, a minus 8, a plus 7. And so what cancels? a minus 8 on the top, a minus 8 on the bottom, and we're going to have a leftover a minus 8 on the top because you can only cancel one at a time. If there were 2 a minus 8s on the top and 2 of them on the bottom, then we could cancel 2. But this way we can only cancel one at a time. Okay, so our final answer is
A minus 8, A minus A plus 7.
okay, a minus 8 on the top, a plus 7 on the bottom, and we're done. Which one? Is there another one we want to do? You guys feel like you could do all those? We can do 19. So the top problem is a binomial. It's not the x thing because it only has 2 terms. So if it's not the x thing, what do? We look for GCF. Okay, so I'm going to get out of here. And I'm going to hit math, go over, down to 9. I'm going to look for the GCF of 8 and 64. What's the GCF of 8 and 64? 8. Okay. So on the top, I'm going to take out the 8. And when I take out 8, what are the leftovers? 1. Yep. 8 divided by 8 is 1. So 1a, and you can write the 1 or not write the 1. Most people would probably not write the 1. They would just say a. A minus 8. 64 divided by 8 is 8. Okay? And then on the bottom, we're looking for 2 numbers that multiply to negative 8 and add to negative 7. And what would do that? Multiply to negative 8, but add to negative 7. Negative 8 and 1. So on the bottom, we have a minus 8, a plus 1. The 2 parentheses that are identical are going to cancel. We got a GCF that can't cancel with anything because there's no GCF on the bottom. Can't cancel with anything. We got a parenthesis that can't cancel with anything because there's no other parenthesis on the top. So we're going to be left with an 8 on the top and the parenthesis on the bottom. Okay, you got about 6 other problems that you're going to need to factor and then do your canceling with, all right? And if you run into any where you're not sure how to factor, just let me know and I'll help you. Okay, our goal is going to be to turn this in before the period's over. That's the goal. So just let me know if we have a hard time with some of the factoring.